Okay, guys, here are the notes for 4-29 and 4-30. So that would be Wednesday and Thursday of this week, okay? So you're really gonna have to pay attention on this assignment. This is 13-4, the sine function. So now we're gonna start getting into the sine and the cosine functions, which you guys remember, sine and the cosine are trig ratios, right? From your trigonometry. Okay, so the objective of this lesson, okay, you're gonna learn to graph, not only graph the sine function, interpret its domain and range, identify the amplitude and the period. Remember, the amplitude is the height of the function from the midline, okay, from that midline. And you guys have that little formula to find the amplitude. Find the period. Remember, the period is the length of one full cycle. Students should be able to graph the sine function if given the equation or properties of this function. All right, a couple things here. All right, the sine function. All right, y equals sine. This little symbol here is theta. Remember that. Matches the measure of theta of an angle in standard position. Remember, that's on the unit circle, with the y-coordinate of a point on the unit circle. The sine curve is the actual graph, okay, of that sine function, all right? And then the sine of theta, the sine of that, angle, is the y-coordinate of the coordinate on the unit circle. Okay, so you guys, we're going to be using, not so much using this, but we're starting right here in standard position, and we're going to rotate around using radian measurements. So the pi over 2, pi, 3 pi over 2, and 2 pi, okay? Just make sure you remember all the way around the unit circle is 2 pi, okay? Halfway around is half of that or just pi, okay? So we're going to be working around this unit circle. Okay, all right, example number 1. And remember, guys, you guys can stop and start these notes as much as you want. Go back through. If you're not understanding something, just rewatch it if I go too fast. All right, so graph y equals sine of theta, okay, in radians. Use the unit circle to fill out the table below. All right, so let's use the unit circle here. You guys should have this sitting right next to you, okay? All right, when theta is 0, okay, when theta, the measure of this angle, okay, is 0, what's the sine of theta? Remember, the sine is that y-coordinate. So the sine is 0. So here's my input. My x-coordinate is 0. The sine is 0. So what if I rotate pi over 2? So pi over 2 brings me right up here. It's 90 degrees, or it's pi over 2 radians. And the sine of that is 1. All right. And if I rotate around the unit circle pi radians, okay, the sine of that is going to be 0. And if I continue around all the way to 3 pi over 2, okay, the sine of that is going to be -1. And then obviously all the way, rotating all the way around to 2 pi, okay, the sine is going to be 0. Okay, so that's in essence what we're doing. We're rotating around that unit circle and finding those y-coordinates as we land on the unit circle. All right, let's look down here. It says find, so again, we're gonna graph this. Okay, we're gonna graph this. Okay, find the amplitude. Okay, if you remember the amplitude, right? We're gonna take 1/2 the max max minus the min. Well, the maximum, okay, for this is going to be 1, okay? And we're going to subtract the minimum, which happens to be -1. Okay, so that's going to end up being 2 over 2 or just 1. So the amplitude of this sine function is going to be 1. find the period of the function in degrees. All right, so let's do this. Before we do this, let's go ahead over here and graph the x and the y. Remember, x coordinates. Remember, these are all just ordered pairs. All right, so 0, 0, pi over 2, comma 1. And you can see here on the x-axis, we have increments of pi. So pi over 2, pi, 3 pi over 2, and 2 pi. All right, so the first one was 0, 0. The second one at pi over 2, the y-coordinate was 1. At pi, it was 0. At 3 pi over 2, it was down here at -1. And at 2 pi, it was 0. Now watch this. If I connect these, okay, you're going to get something that looks like that. And that's not my best sine graph, but it should be a curve. All right? And I think you guys have all seen this sine function before, that curve. Remember, all right, that keeps going on and on forever. So look, now let's find the period. Remember, the period is the length of one cycle. So one cycle, start here, and the pattern ends there, okay? So in degrees, that would be 360 degrees. In radians, okay, that is 2 pi. Okay? All right, find the domain. Remember, the domain are the x values. So the domain is going to be -infinity all the way to infinity, because this graph continues on in both directions. Okay, just because we have just one cycle, it doesn't actually stop. And the range, would you guys be able to figure out the range? Remember, the range are the outputs or the y values. My maximum is 1 and my minimum is -1. So I go from -1 up to 1. And we put the brackets because we don't go any further. We don't go any less than -1 or greater than 1. All right, okay, page 2. All right, up in this box, you guys, we have just some variables here. So the absolute value of A is your amplitude. Okay, B, all right, we're looking right here. In this equation, A is going to be your amplitude. B is the number of cycles from 0 to 2 pi. So if we went back to this one, from 0 to 2 pi, we would only have one cycle. So in that example, your B value would be 1, okay? Because we have just one cycle from 0 to 2 pi. All right, that's B. And then your period, we can find the period by taking 2 pi over B. So as long as we know how many cycles we have, okay, we could figure out the period, which makes sense, okay? Because if we know how many cycles we have from 0 to 2 pi, all right, we plug that in, we can divide that by 2 pi, and that will give us what the length of the period is. Okay? All right, and then obviously P stands for the period, but this is what we're going to be using right here. This y equals A times the sine of B times theta. Okay, that's what we're going to use today and from this point on. All right, let's look at this graph right here. It says when A is greater than or equal to 1, when this number right here, this variable here, when this term is greater than or equal to 1, the key points are, okay, all right, you have, they call it on here an intercept, but I like to call it a 0, all right? So you're gonna have a 0, maximum, 0, minimum, and 0, okay? So if you go, once again, go back to the example that we did to start, all right? We have a 0, max, 0, min, 0. All right, all sine functions, okay? We'll start here at the origin, 0, okay? So we have the 0, max, 0, min, 0. And those 5 points, you guys, this is how you're gonna graph these from this point on, by graphing those 5 points. All right, so you can see here again, 0, max, 0, min, 0. Now, what happens if I plug a negative in for A? All that does, like every other function we've had, will flip the function. So instead of going up, down, and up, it goes the other way. So now we have a 0, a minimum, 0, max, 0. Still have the exact same points here, okay? But it's reversed. Okay, see that? So this is right here is when A is greater than 0, or 1, sorry, or equal to, and this is when A is less than or equal to negative 1. All right, that negative sign just flips it. Okay? All right. Let's go down here. Example 2, use the graphs below. Find the number of cycles. The number of cycles, remember, that is your B term, from 0 to 2 pi, because 2 pi is one rotation around the unit circle. Find the period and the amplitude of each function, write the equation. So they're going to give us the graph, and we're going to come up with the equation by finding all those points. Remember, we're going to use this. Y equals A, okay, sine of B theta. That's my template. All right, so let's see here. Obviously, it goes from 0, and this is kind of hard to read, but this is a 2 pi. Okay, so 0 to 2 pi. All right, so let's look. We have, if I highlight here, okay, there's one full cycle. I use a different color here. There's another cycle. So how many cycles do I have from 0 to 2 pi? I have 2 cycles. All right, to find the period, remember, to find the period, I'm going to take 2 pi over B. All right, in this case, my B value is equal to, what, 1, 2. So this is my B value, right? So let's plug in 2 pi over 2, and that comes out to just pi. So the period is just pi, which makes sense. Look at one full cycle ends here at pi. All right. All right, the amplitude, okay, amplitude. Okay, so remember, it's going to be 1/2 times 1, okay, minus a negative 1, okay, which is going to be 2 divided by 2, which is just 1. So my amplitude, again, is 1. All right, so here's my equation. I'm going to take this right here, so y equals, and I'm just going to plug in the information. All right, what's my amplitude? My amplitude is 1. I don't have to put it, but I'll put it 1 times sine, okay? What's my B value? My B value, because I'm going to plug in right there, is 2. So parenthesis 2 theta. Okay? There's my equation. Okay, let's look at the next one. Let's look at B. Notice again how this one and this one, they're initially going from your origin and they're going up. That means that the A value is going to be positive. Same thing with this one. All right, so from 0 to 2 pi, there's 2 pi. I've got, let's see here, 1 cycle, 2 cycles, 3 cycles. All right, so once again, that's your B term. The period, all right, the length of one cycle. One cycle goes from here to there. Now remember, if you can't figure that out, if you can't see that that's 1/3 of the way through, you could take 2 pi over your B value, excuse me, and there's your period. 2 pi over 3. All right, so you got, and see if that makes sense. You have 3 cycles from 0 to 2 pi. So the length of one cycle would be 2 pi divided by 3, since there's 3 cycles. All right, my amplitude, okay. All right, I could use my little formula, or I could use this. This is my midline. Okay, from my midline to the maximum is 1. So my amplitude is just 1. My A value is 1. So here we go. My A is 1. The B value is 2 pi over 3. So here we go. So y equals, again, I don't have to put the 1 there. So I'm going to put sine. All right. And the B value is 3 and theta. Okay. And there's my equation. All right. And I'll show you in the next set of videos how to check this on your calculator. Okay? All right. Next page. Next example, let's look at A here, guys. All right. All right. So once again, we're starting at 0. We're going all the way to 2 pi. Notice how it's going in a downward direction. So now we have a 0, min, 0, max, 0. All right. That's one cycle. Hopefully you guys can see that there's 2 cycles, all right, from 0 to 2 pi. So that means that the period, okay, the length of one cycle is just pi. The amplitude, okay, from this midline, okay, all the way up, it looks like my amplitude in this case is 3. So y equals negative, okay, 3 parenthesis. You don't have to put the parentheses, sometimes I do. Sine, okay, of 2 theta, or y equals negative 3 sine 2 theta. And sometimes you'll see that parenthesis there, sometimes you won't, but there's your answer. Okay. All right. B. All right, looks like we have what? Just one cycle. Look at that. One cycle from 0 to 2 pi. So the period, the length of that cycle is 2 pi. The amplitude looks like it goes from my midline up to 4. And we are starting in a positive direction, right? We're going up. So y equals 4 sine theta, because my b is 1. So b is 1. There you go. Y equals 4 times sine of theta. Okay, fantastic. All right, let's look at this one down here. Now, what gets a little difficult, and I think the most difficult part of doing these is coming up with those increments. So we're going to try to make it very easy on you, okay, those intervals. All right, it says example 3, sketch one cycle of the sine curve with an amplitude of 2, and a period of 3 pi. Use the 5-point pattern, the 0 max, 0 min, 0. Write the equation for the graph, okay? All right, so here we go. So y equals, all right, what's my A? My amplitude is 2, okay? It says I have a period of 3 pi. All right, so let's go sine. All right, now look at, in order for me to figure this out, I need to put the B value here, right? I need to put the B value. So how do you find B? Remember, I'll put it right here. B is equal to, if you remember back from our notes, okay, if I can find them right there, okay, all right, to find the period, all right, is 2 pi over B, 2 pi over B. Well, if we know that the period is 3 pi, so I'm going to take 3 pi is equal to 2 pi over 3. All right. And then what we can do, so this is my period here, 3 pi. Okay, 3 pi is equal to, now you know what we'll do? We'll do this. We'll keep this as b. Sorry, we'll keep that as b. All right, okay, so watch this. Because we don't know what b is, we're trying to find b. So I'm gonna, since this is a proportion, I can cross multiply. So this is gonna be 3 pi times b is equal to 2 pi. Divide both sides by 3 pi. I got b is equal to, now look what happens with the pi's. B is equal to 2/3. All right, so just revisit this, guys. What I did, and this is kind of hard concept to grasp, okay? I knew what the period was, so I took the period and set it equal to 2 pi over b. And the reason why I did that is because that's the way that we find the period, 2 pi over b. All we did was we knew what this was. So I cross multiplied, okay, solved for b, and that gave me my b. Now what that does is it gives me a chance to plug that in, 2/3 times theta. And there's my equation. Okay? All right, so what I did here, in order for me to get these intervals here, is I know that I have to start at 0, 0, the origin, standard position, and the period is 3 pi. Remember, the period is the length of one cycle. So the cycle, whatever it looks like, should start and then end at 3 pi. And then I worked my way backwards. So half of 3 pi, okay, is 3 pi over 2, or just 1.5 pi, and work backwards that way. Or what you could do is this. If this is 3 pi, and this is from 0 to 12, because I counted that out, okay, 1, 2, 3, 4 would be pi. Another 1, 2, 3, 4 would be 2 pi. And then 1, 2, 3, 4 would be 3 pi. All right, you can work backwards and label all of these. Okay, so if this is pi, half of that is pi over 2. Half of that is pi over 4. Okay, this is 5 pi over 4. Okay, this is 7 pi. 7 pi over 4. Okay, and you guys can fill those in the rest of the way. All right, so now, look at my key points here. All right, we're going to start at, okay, 0, 0. All right, and I'm going to go up. Remember, my amplitude is 2. My amplitude is 2, so I'm going to go the first. So I've got 1. Let's see here. 1, 2, 3, 4. Okay, so here are my 5 numbers here. 1, 2, 3, 4, and 5. Right? 1, 2, 3, 4, and 5. Okay, so my first key point, 0, 0. I know I'm starting here. All right, now I'm going to go up because I know it's positive to an amplitude of 2. So let's just say that this is 1 and this is 2. And the reason why I know I'm going up to 2 is, again, that's my amplitude. So from this point, I make another dot. Okay, so I'm going to go 0, max, back down to 0. My minimum is going to be -2 because this is -1, this is -2, and then back down to 0. So here are my 5 numbers again, guys. Look at 0, max, 0, min, 0. All right. And if I have to put these as ordered pairs, my maximum is what? 3 pi over 4, comma 2. That's this point. Back down to this. 3 pi over 2, comma 0. Down to my minimum, which is, all right, if this is 2 pi, this would be 9 pi over 4, and you can calculate that out. So this would be 9 pi over 4, comma, -2. And this point here would be 3 pi comma 0. Okay, 5 numbers. Let's do it. We're gonna. Don't worry. You can pause that, reverse that, do whatever you need to. But we're gonna do another one here, and hopefully it'll make a little bit more sense as we keep going through these. Okay. All right. Look at this one. Okay. Sketch one cycle of this equation: y equals -3 sine 1/2 of theta. Now, what I noticed right away, it's a -3. That means that it's going to start by going down to a minimum instead of going up to a maximum. All right, so from this, I know that my amplitude is -3. So remember, we just say that the amplitude is always a distance, so it's always positive. So the absolute value of -3 is just 3. The period, all right, once again, look at, I know what the B value is here. They give this to me this time. So my period is 2 pi over B, or 2 pi over 1/2, or when you divide by a fraction, you flip that around and you multiply. So 2 pi times 2 over 1, which is 4 pi. All right. Okay. So my 5 important key points here, okay, is my 0, minimum, 0, max, and 0 again. All right, so we know that we're starting at 0, 0, that standard position. And what I did was this. I know 4 pi. So what I did was I just skipped and I went, half a pi, pi. There's 1 pi, 2 pi, 3 pi, and 4 pi. All right, this is 4 pi right there. And then I just split those off because look at, okay? So I've got 1, 2, 3, 4, 5. Those are the 5 key points. So once again, okay, go out to that full cycle, okay, the length of that period, and then cut that in half, and then find the midpoint between those two, and then those are your 5 numbers here. Okay, so my amplitude is 3. So we're going to go 1, 2, this is -3, and 1, 2, +3. Okay, all right, so here we go. Go down over to pi, down to -3, 0, max, and then back down to 0 again. You guys get to use your art skills a little bit, and there you go. That is the graph of that equation right there. Okay? All right, let's do one more here, guys. Example 5, sketch a graph of y equals 2 sine of 2 theta from 0 to 2 pi. All right, from 0 to 2 pi. All right, so look at, I'm gonna start here at 0, and I'm gonna go, all right, let's do this. Let's go 1 pi. All right, so this is 2 pi right there, 3 pi, and 4 pi. I am gonna sketch just 2 cycles of this. I know it says 1, but I'm gonna sketch 2 for you guys. All right, so let's look at my information here. So look at, all right, I have 1 key point here, and this is the end of my cycle. Half of that, half of that, half of that. So 1, 2, 3, 4, 5. Those are the 5 numbers I'm gonna use, okay, to draw my cycle. Okay, since I'm going up in a positive direction, it's going to be 0, max, 0, min, and then back down to the 0 there, okay? All right, we'll just label that as pi. All right, amplitude is the absolute value of 2, which is 2. The period, okay, remember the period is 2 pi over b. In this case, b is 2, okay? So it's going to be, the period is going to be pi. All right? All right. So let's see here. All right, so I know my amplitude is 2, and we'll go up. This is 1, 2, -2. All right, so let's start at 0, 0. So my first point is 0, 0. And since, again, this is going to go up, I'm going to go up to a maximum. My maximum, okay, is going to be, all right, so let's see here. I think I might have to change this, you guys, all right? Because I'm looking at this now. I don't know if I can squeeze it all in there because according to this, the period is 1 pi. So let's just, I'm going to change this for you guys, okay? All right, let's do this. Let's go pi and 2 pi. All right? Okay, so watch why I did that. Because at first, the maximum is going to be pi over 4, and we're going to go up to 2. So look at, I go here, up to here, 0, down to 2, and then there. I know it's kind of hard to see, but look at, I start at 0, 0, I go up to my max, my 0, my min, and my 0. So the reason why I pushed that pi, I had to erase those and push those back, is because I wanted to be able to fit that in there nice and evenly. All right? And it's sometimes easier to label these points after the fact. So this is pi over 2, okay? This coordinate is pi over 4. This coordinate right here is 3 pi over 4, and then pi. All right? So then I go from my 0 here to my maximum, back to my 0, okay? And that is at pi over 2 comma 0. Okay, I go to my minimum, which is 3 pi over 4 comma -2. That's this point right there. I go to my 0 here, okay, which is at, all right, pi comma 0. Now, if I wanted to sketch another graph of this, all right, since I have 1, 2, 3, 4, perfect, okay, I go back up to 2, to 0, -2, and then to 0. And then I can just sketch in another curve of that. All right. Okay, so you guys, I know that this stuff is not easy. And we're gonna try to simplify this even more next time. So your homework, make sure you guys are working on that. Your homework is 13-4, the sine function worksheet, which looks like this. Okay, and you've got a front and a back to that. Okay, so you're gonna do both. Okay, you're gonna do both sides, okay? So you've got this side here, and you have that side there, okay? All right, thank you guys. Have a great day.